Hello, my name is Virginia Field. I'm in Physics 223, and today I will be doing problem 8 off of homework 11. A 1.7 kilogram mass on a spring has a displacement as a function of time given by the following equation. A time, and the first one says, what is the time for one complete vibration? So we're finding the period, which is equal to 2 pi over kind of the velocity here. So, the angular velocity is 4.09 because that's kind of how that's part of the formula. So we find the period of 1.54 seconds. Next, I asked for the spring constant. So in the problem, we're given 1.7 kilograms as the mass. So we have that, and we also have the velocity. So all we have to do is solve for k, which is easy. K equals the velocity squared times mass. So the spring constant is 28.44 Newton meters. The next part asks for the maximum speed of the mass, so the maximum velocity is the velocity times the amplitude, or the x displacement is the greatest. So 4.09 times 7.9 centimeters, because it asks for the answers in centimeters per second. So maximum velocity is 32.31 centimeters per second. Next part is the max force on the mass. We just found out in the previous one what the spring constant was times, because we wanted newtons, the distance in meters, so that's just what the amplitude would be. And then we get the maximum force equal to 2.25 newtons. Next part gives us the time. At time equals 1 second, what is the x? First it's asking what's the x, so all we do is plug in 1 second into the equation that we're given, and we find that the displacement is negative 0.31 centimeters. The speed, the equation that we use for it is the velocity times amplitude times sine of the same of the center part right here, and we get the speed to be 32.3 centimeters per second. The last part of that is it asks us to find the acceleration, and the acceleration equation that we get from this equation right here is negative velocity squared times amplitude cosine, this part transposed, and the acceleration at time equals 1 second is 0.0518 meters per second squared. Last part of this problem is finding the force at this time, 1 second. So the force equals spring constant times the distance. We found the spring constant right here. We also found the distance at 1 second. We gave the answer in centimeters, where we need to find newtons, so we make that 0.0031 meters, and we get the force, 0.0881 newtons. That's it.